You already know smoking doesn't help you live longer. So here's the problem. A real public health study tracked 1,300 women across 20 years, and when researchers checked who was still alive at the end, the smokers outnumbered the women who never smoked. Every figure in the report was verified. No manipulated data, no fake chart, no statistical error anyone could find. So now you have two things that cannot both feel true at the same time. So where's the lie?
The study is real. In the early 1970s, researchers surveyed a district called Whickham near Newcastle in the north of England. They recorded who smoked and who didn't. Then they waited. 20 years later, they checked who was still alive. The outcome was simple. Not symptoms, not opinions, survival. And the numbers were not subtle. Among the women who smoked, 76% survived. Among the women who never smoked, 69% survived. The non-smokers died at the higher rate. Read plainly, the conclusion seems unavoidable. Smoking somehow was keeping these women alive. But every figure here is accurate. The survey was careful, the follow-up was thorough. Nothing was faked and nothing was miscounted. That is what makes the result difficult to dismiss. If the data is this solid, then the mistake cannot be in the arithmetic. It has to be somewhere else. The obvious one is that smoking itself somehow helped. Maybe it reduced stress. Maybe it calmed nerves. Or maybe the whole result is just statistical noise. But noise does not survive 1,300 women. The sample is too large and the pattern too consistent for random chance. And nothing we know about cigarettes turns them into a survival aid. So it was never really about smoking, which leaves one place for the answer to hide. The two groups of women were not the same to begin with. Something about who ended up in each group is bending the result. We just have to find what. The thing that differed was age. And here is the trap. The women were a genuinely random sample of the town, but random sampling does not make smokers and non-smokers identical groups. In this sample, the smokers skewed younger, and over 20 years, age matters far more than a cigarette ever could. So split the women by age and look again. Among the youngest women, 18 to 44, 93% of smokers survived against 96% of non-smokers. In the middle group, 68 against 74. Among the oldest, 14 against 15. Look down that column. In every age group, the non-smokers had the higher survival rate. Smoking was never the safer side of the line. But combine those same groups back together and the pattern flips. Overall, the smokers appear to survive more often. The same data, the same women. In every age group, smoking looks worse, yet combined, it looks better. That is not supposed to be possible.
To see how that strange result is possible, look at who is actually in each group. Among these women, smoking was far more common in the young. The older women had mostly never taken it up, so the non-smokers were already a much older group before the study even began. On the chalkboard, the imbalance is simple to see. About 1 in 4 non-smokers were 65 or older at the start of the study. Among smokers, it was closer to 1 in 12. Now think about what 20 years does to a population. Older women are far less likely to still be alive after 2 decades, not because they avoided smoking, but because they started out older. Age alone changes survival dramatically. So when all the women are pooled together, the comparison quietly shifts. The non-smoker group carries far more old age than the smoker group, and old age comes with lower long-term survival. That extra weight drags the non-smoker's overall average downward. The total was never really measuring smoking by itself. It was mostly measuring age wearing smoking's clothes. Now split the women back apart by age and the disguise disappears. Compare younger smokers with younger non-smokers. Then compare older smokers with older non-smokers. Within each age group, smokers actually have lower survival. The apparent reversal only appeared after combining groups that started from very different places. That kind of reversal has a name: Simpson's paradox. A pattern holds inside every subgroup, then flips when the groups are combined. And the hidden variable bending the result, the one quietly steering the outcome, is called a confounder. Here, the confounder is age. That is why careful statistics insists on comparing like with like. The numbers were never lying. They simply answered a different question than the one we thought we were asking. And this wasn't a quirk of one carefully chosen example. The same reversal appeared in one of the most studied university datasets ever collected. In 1973, Berkeley's graduate admissions numbers looked stark. 44% of male applicants were admitted. For women, it was 35%. On the face of it, the gap looked like clear discrimination. Then, the data was split by department. And department by department, the pattern changed. In several departments, women were admitted at slightly higher rates than men. In others, the rates were nearly identical. The difference came from where applications were concentrated. Women applied far more often to the most competitive departments, where admission rates were low for everyone. Men applied more heavily to departments with higher acceptance rates. So the overall number told one story, but the groups underneath it told another. Same illusion, a single statistic hiding the structure beneath it.
It only gets bigger and stranger from here. Subscribe and like so you don't miss what's coming.